Mrs. M. Priyadarshini, ME MBA, is doing PhD, is currently working as teaching fellow in the Department of IST, Anna University, Chennai. She completed a Master's in Software Engineering from Anna University. She has about 10 years of experience in handling courses for UG and PG. She was serving as Technical Evangelist for Corporate over 4 years in Java Enterprise Technologies, Software Engineering, Databases, OOAD, and Design Patterns. She is proficient in handling IT projects as well into concept development for enterprises. She is doing a research in the area of web services security. Her other areas of interest include software engineering, OOAD, databases, enterprise technologies, and service-oriented architecture. She holds many journal publications and conference proceedings in her research area.
Welcome to UGC lecture series in Computer Science, Java Part 11. So in today's session, we are going to see about collections framework and about various interfaces that is available in collections framework, and then the class hierarchy of collections. So first we'll see what is Java collections framework. So Java language API provides many of data structures. It defines a collection as an object that represents a group of objects. So we'll see what is collection. So already I told you that you have an array data structure which could store elements of same data type. It may be a primitive data type or it may be a non-primitive data type. If it is a primitive data type, for example, an array of integers. If it is a non-primitive data type, an array of strings. So similarly, I can even have array of employees, all the objects. So array stores contiguous memory allocation. So the disadvantage of array is whenever you initialize an array with a particular maximum size, you cannot add the values. So dynamically you cannot add how many elements you like to add in your array. So for that we have a framework called collection frameworks that is available in java.utilpack, where I can store a collection of objects. So for example, I can store n number of employees. So I need not worry about the maximum limit that I am trying to store in that particular collection. So it defines a collections framework as a unified architecture for representing and manipulating collections, allowing them to be manipulated independent of the details of their representation. So it means that here in collections framework, we have lot of interfaces. So whenever I say interfaces, so it means that the class is the one which has to implement that particular interface and bring into existence. So here we have some method of abstraction. So the way in which your collections data that is available in your collection is stored is abstract from that of the class that we use. So we, instead of worrying about how we store the data, we are worrying about only how we are going to store and retrieve the data. So we never worry about what is the data structure that is at the back end which is used to store your collection of data. So now we look into generics. So generics are the way to define which types are allowed in your class or function. So you can see that here I have a variable of type list. Here I am trying to add an integer to that list, and here whenever I take the value from the list, I need to typecast it to the integer. So if at all I have a value in this particular list to be a float, then I need to typecast it to float. So you can see here I have specified what data type that I am going to store inside my list in form of a template. So this is called generics. So again here I need not specify into what type it need to be typecasted. So in programming languages like C and C++, we have options called template. So we have class template as well as we have function template. So class template is nothing but, so whenever I have a class, so I am trying to use that class for handling integers. I am trying to use the class for handling float values, for double values. So, for all these I need not write the class again and again, provided the mechanism what I use is same. So, in that case what I do, I create a template, so that on that template I can say that I am going to use a class which is going to handle integer, a class which is going to handle float, a class which is going to handle double. So, similarly I have a function. For that function I give a parameter, so the function can handle an int or float or double. So, instead of that I give a generic or template, so that is my function template, so that I can give any values as the parameter to the same function. So, I will have only one implementation, whereas I can use many data types for the same function. So, that is what is said to be generics. So, in Java we have in collections framework we can use all data types in one particular type of collection. So, first I will introduce you with few interfaces. So, there are two main interfaces for all the collection types in Java. So, one is collection, another one is map. So, you can see here E, the data type that your collection is going to handle. So, or object. So, here we never specify, only primitive data type could be handled. So, this E can be any object. I can have a collection of integers, integer objects, I can have a collection of string object, I can have a collection of employee objects. So, this means that it can handle non-primitive data types also. So, here next is map. So, map specifies a key and then a value. I have a key as well as value. So, it is a key value pair, that is said to be map. So, whenever I say map, one entry will have one key and a value. So, you can see that collection is the base interface, and from that interface I have an extended interfaces set, list, queue, and in set I specifically have sorted set. Other than this, for map I have sorted map. So, collection is actually an interface. Each kind of collection has one or more implementation. You can create new kinds of collection. So, user can create their own new type of collection. So, that is what is advantage of your Java. So, it is an open source, just you can keep on creating your own collections based on already available interfaces as well as the classes. So, you can see here the collection interface provides the basics for list like collections in Java. So, the interface includes, you have add method. So, I am adding an object. So, I can add any object into my collection. So, and then I have add all. So, add all in the sense, again this could add collection, not an one single object, it is going to add a collection of objects. So, next is I can clear my collection. So, contains, so I can check whether this object is available. So, next I can check whether this collection is available in a particular collection, and then I can check whether a particular collection is equal to a particular object. I can check whether is empty. So, all these are methods in collection interface. It is not the method in any of the class. Since these methods are declared in the interface, if somebody is trying to create a class, it becomes their responsibility to implement. So, already in Java API, they have created many number of classes which implements the collection interface. So, they have implemented all these methods in their own fashion. So, the way in which they store and the way in which they retrieve the objects in the collection is different with respect to each classes that is available in the Java API. So, we have iterator. So, this iterator is used in order to retrieve the values from the collection. So, I can remove an object, I can remove a set of collection, and then after removal I can retain all the values, I can get the size of the collection, and then I can even change the collection to an array. So, even I can have an array and then I can specify the object. So, it can again be this means that it is a collection again. So, you can see that collection interface is available in java.util. So, here we have a class itself called java.util.collections. So, this provides a number of algorithms for use with collections. So, algorithms like sort, binary search, copy, shuffle, reverse, max, min, etc. So, you can see that we have an employee, maximum salary. So, here collections.max. So, it means that I am having a method called max in this collections class, and then I am passing a particular collection as a parameter. So, say a set of employees, collection is nothing but a set of objects. So, I am passing this set of objects from where I am trying to generate the maximum value. So, you can see that here max is a method which is given directly with the class name. So, if at all I can directly access a variable of a particular class without the instance, so obviously your variable should be of type static. So, your collections class does not have any instance variables, it has a set of static variables which could be accessed. So, using this collections class I can just add values into that collection, I can remove the values into the remove the value from the collection, everything I can do, and the methods here are static. So, it means that without instantiating it I can just use it. So, this is a mechanism which is used in order to add values in any of the collections. So, I can give the collection name and then I can add the values to that particular collection. I need not worry about what type of collection it is, whether it is an array list, whether it is a linked list or so. So, first we look into what is a list interface. So, list allows duplicate entries within the collection. So, lists are an ordered collection much like an array. So, list grows automatically when needed. The list interface provides an accessor method based on the index. So, as specified, list is an interface. So, list is not going to be instantiated, whereas we create object references for list. So, what we do is, if we want to have a variable of type list, so it can point to any type of class which has implemented the list interface, and then you can have duplicates. So, with respect to list I can have the same object again and again. So, I can duplicate the values that is available in the list. So, also I can dynamically add the contents, not as such in your array. So, here you can look into the methods that are available. List interface extends the collection interface and add the following methods to the collection. So, these are all the methods other than what I have in my collection interface. So, void add, I can add a particular index, an object, add all, I can add a collection, and then I can get a particular object from that collection. Index of, I want to know the index of a particular object in the collection of objects. I want to know the last index. I can have the list iterator. So, I can use list iterator which will return me the list of elements that is available in the particular list interface. So, and then I can remove, I can set some value on that particular index, and then I can create a sub list. So, if I have 10 number of elements, if I want another list to be created with 5 elements starting from a particular index to the end of a particular index, so I can very well create a sub list of it. So, next is a set interface. So, set interface also extends the collection interface, but does not add any methods to it. So, I do not have any specific methods in the set interface. So, collection classes which implements the set interface add stipulation that sets cannot contain duplicate values. So, elements are compared using equals method. So, you can see that the difference between your set as well as your list is I can have duplicate values in the list. So, I can create, I can add the same object again one more time in my list, whereas in set if I try to add one more object in the list in the set, I will not be able to add it. So, unique values only will be available in the set. So, next is sorted set. So, sorted set provides same mechanism as the set interface, except that sorted sets maintain the elements in the ascending order. So, whenever I add an element to my sorted set, so it will be automatically sorted based on the object. So, objects will be considered, and each and every, so once I insert a particular object, automatically this will be stored in form of an ascending order. So, whereas in case of your set, whenever I add, it will be added at the end of the element. So, if I have 10 elements, so it will be added as 11th element, whereas if I add an element in my sorted set, automatically my elements will be assigned the place where in which sorting order it has been sorted. So, ordering is based on natural ordering, comparable or using comparator. So anyway, we are going to see about comparable and comparator later on in this session. So next is your map interface. So already I told you that from your collection interface you have three interfaces, one is list, set and other one is map. So we will have a short break and continue with the map interface. So now we will continue. So we will see about map interface and all the other classes that is available in collections framework. So map interface provides basis for dictionary or key based collections in Java. So the interface includes methods such as clear, contains key, contains value, entry set method which is going to enter your set, and then equals which is going to check for the equality of the objects, and then we are going to get a particular object. So check whether it's empty, set the value for the key, and then for a particular key I am going to set the value. So then object I am going to put a key value pair. So already I have told you that in a map we will have a key and value. So we will put all. So again we will have a map that will be put in another map. So and then we are trying to remove an element with the particular key, and then size, and then values will give a collection of values. So this map interface normally is used in cases. So for example, I maintain a particular set of key value pairs, like so for example I am monitoring the network. So in that case I try to store a key value pair such as which user has most access, which user has last access the network. So everything I can just maintain in a temporary map. So which could be used for the purpose of maintaining your network or referring to some. So for example, if I am trying to shut down, which user has shut down and what is the problem, that and all I can have it as a key. So here in map your key will follow your list and then your value will follow the set. So for example, the user who has last logged in and user who has shut down your system, both may be the same. Sometimes user who have logged out, so in that case my two keys will be different and the values may be same. So your key follows set whereas your value follows your list. So it means that which can repeat. So here you can see the class structure. So we have collection, under that we have list, abstract collection, your set. So here we have abstract list, abstract set, and abstract, this could not be instantiated. After abstract list I have abstract sequential list, vector, array list. We can see the class hierarchy here. So here we have three interfaces, basic interfaces, collection, list and set. So here we have an abstract list, a class which has implemented list, and then we have abstract sequential list which has implemented the abstract list. So whereas these two are abstract, you cannot instantiate, whereas here we have abstract set which could also not be instantiated. Whereas your linked list is a class, vector, array list, hash set and tree set. All these could be implemented. So if at all I want to create a list, I can create the list as a linked list or array list or your vector. So we'll see what are all the various types of lists available. So Java provides three concrete classes which implements the list interface: your vector, your array list and linked list. So first we look into what is a vector. So vector tries to optimize storage requirements by growing and shrinking as required. So the methods are synchronized. So in case of multi-threading, so if 2 or 3 persons are trying to access this particular vector, so automatically the synchronization process will be available by default in your vector. So you can see here a vector V is created with initial size of 3 and an increment of 2. So already told your vector could dynamically be updated. So the allocated memory of your vector could be allocated dynamically, or else incremented dynamically. So here the initial size is 3 and 2 we have given that. So automatically for 2 objects your memory will be reallocated. So first I have 3 values. So if my memory is not enough, so automatically 2 other objects memory will be allocated. So here I am trying to print the size and then the capacity. So size is the maximum size and what is the capacity? Now I have stored, and then I am trying to add an element. So here I add an integer object. So here we have v dot first element. So in the vector I can access the first element as well as the last element. So here I can check whether a particular integer is available in the particular vector. So if it is available, just I can know that a particular element is available in the vector and I can do the manipulation accordingly. And one more thing is, here if vector is considered, you can go into the first element, you can go into your last element. If you try to access any of the elements in your vector, which is possible, whereas in the other cases, if I go in for my array list, I cannot access my first to last element as well as the elements that is in the middle as such whenever I like. So we can look at the array list. Array list is roughly equivalent to vector, except that its methods are not synchronized. So whenever multi-threading is used, your array list could not be synchronized, whereas your vector is synchronized. So we have a list in object reference of list, whereas I created an array list. So it means that an array list is created, whereas this list AL can only access the method that is available in the list interface. So this we have already seen in our previous session how this object reference is being made. So here I am trying to access the size, add and remove. So here all these size, add, remove, all these methods are available in the list interface. Next is our linked list. So here the list will be created in form of array, whereas here the list will be created in form of linked list. So it means that there will be a pointer which will point to the next elements in your linked list, whereas in array it will be contiguously stored. That is what I told you, this is abstract. Whenever I access the class, I need not worry about how it is being stored and how it is being retrieved. So linked list implements a doubly linked list of elements. So here methods are not synchronized. I am having a linked list and I am creating a new linked. See here you can see that I have created an object of linked list. Provided if you are going to use only the methods that is available in the list interface, so in that case I need not create an object of linked list. It's enough if I create an object reference of list. So based on the purpose you have to design, but maximum what we do is we use all these collections in order to add and remove elements only, nothing else we are going to do. So in that case always it's a good practice to create an object references of the interface instead of always creating, because unnecessarily we are trying to provide the space for all the methods which are not available in that particular class. So I am going to use only the collections methods. So that is only the methods that is available in my interface. So in that case I need not create an object of type linked list. So here you can see that we have added elements, few elements, and then we have few methods like add last and add first. So I can add elements in the last, I can add elements in the first, and then even I can add with respect to index. So at first place I am adding an element. So I can remove an element, I can remove an element with a particular index. One more thing is here, since I can go in for last and then first, so it's more suitable for handling your queue as well as your stack type of data structure. So if I am going to create a stack or queue, so I can get the help of linked list instead of going in for array list, because in array list I cannot add elements as such wherever I like, in whichever index I like. So here even I can use remove first and remove last. So again I can get a value, that is the values here again an object only. So I can set on a particular index a particular data type. So here you can see that this is concatenated and it has been put in the subscript of 2. So an iterator is an interface that enables you to traverse through a collection and to remove elements from the collection selectively. So if desired, you get an iterator for a collection by calling its iterator method. So normally for all collections I have a method called iterator which will return the iterator for that collection, so that I can go and access all the values that is available in the collections. So you can see this, we have an interface called iterator which can hold any data type. So I have method called hasNext. I want to check whether there is any element next in order to get my element. If I want to remove also, I can remove. So similar to that of iterator, I also have another enumeration. So here enumeration acts as a read-only interface because it has methods only to traverse and fetch the object. Whereas here I can remove. In my iterator I can remove, and in my enumeration I cannot do it. So enumeration, so I have vector.elements, it has been assigned to enumeration. So I can browse through it. I can go in for next element, I will check whether I have more elements. If so, I go into next elements and I can print it. Iterator is more secure and safe as compared to the enumeration because it does not allow other thread to modify the collection object while some thread is iterating over it, and throws, in case it throws a concurrent modification exception. So that is what is difference between your iterator and enumerator. Iterator is more secure and safe than that of the enumeration because all your synchronization process, everything is good with respect to your iterator. So next we will move into set. So here we have two types of set. Java provides two concrete classes which implement the set interface, hash set and tree set. So hash set behaves like a hash map except that the elements cannot be duplicated. So since it is a set, it could not be duplicated, whereas hash map, your elements could be duplicated. Your tree set behaves like a tree map except that the element can. So since it is set, you cannot duplicate it. So with respect to maps, Java provides three concrete classes: hash map, weak hash map and tree map. So hash map is the most commonly used map, provides access to elements through a key. So normally I will have a key, based on the hash value of the key, that element will be stored. So you know what is hashing. So I have a key value based on, so for example, I have an employee ID. In the employee ID, I consider only the number of the employee. So I may have an employee ID which specifies which department that employee belongs to and number of the employee. So for example, IT is the department and 052 is the employee number. So in that case, I can have a hash value. So IT, my department, can be taken as a hash value, and all the values that belongs to that particular hash value will be stored in a particular place. So this is how your hashing function works. So here we normally have hash map. So here access is through the key. The key cannot be iterated if they are not known. So weak hash map, same as that of your hash map, provides the same functionality as map except that if the key object is no longer used, the key and its value will be removed from the map. So it will take a few period of time, and then after a period of time, if that particular key is not used, then automatically that will be removed from the memory. That is from your hash map. So next is your tree map. So in case of tree map, your red-black implementation of the map interface is considered. So you know what is red-black. So once you have an element in the tree red, so next your black should come. So both the values red and red should not come. So next is about comparable and comparators. Java defines two ways of comparing objects. So the object implements comparable interface. A comparator object is used to compare two objects. So two ways, one is using one interface or using a class. If the objects in questions are comparable, they are said to be sorted by their natural order. So if I say both are comparable, it means that they are sorted by natural order. Comparable object can only offer one form of sorting. So only one form of sorting could be offered. To provide multiple form of sorting, comparators must be used. So if I say comparable interface, so we have a method in that which is going to compare. So in that case, I can only use one particular type of sorting. Whereas if I am using comparators, I can go in for any method, whichever I like. I can have 2 or 3 mechanisms to do it. So you can see here, you may recall a method from the string class. So int compare to, I am comparing to an object. So object will be compared to another object. This method returns 0 if the strings are equal. So this is, we are speaking with respect to string. If this object is less than the specified object, less than 0 value, or if it is greater than specified value will be. So your left hand side string and then your right hand side string will be compared. So comparable interface contains compare to method. If you wish to provide a natural ordering of your object, you must implement the comparable interface. Any object which is comparable can be compared to other object of the same type. So whenever I am trying to compare two objects, both of them should be of same type. Then only I can implement the comparison mechanism, because again it is in natural or ordering also, provided if it is in comparable interface. So here in comparator interface, we have two methods. One is int compare one object with that of the other objects. So 0 if the objects are equal, less than 0 if the object is less than the second object. and greater than 0 if the first object is greater than the second object. So, here we have seen that you are going to access this method with respect to a particular object, whereas here you can see that I am comparing the two objects here. So, next is equal. So, equals is a method which takes object as the parameter. So, returns true if the specified object is equal to this comparator. So, that a specified object provides the same type of comparison that the object does, same mechanism is used. So, as a summary, so we have seen about collections framework, what are all the interfaces that is available in collections framework, and then we have also seen what are all the various classes that has been implemented by Java and then is being provided to us in order to work on collection of objects. So, from this session we will be able to answer questions like list of collection interface, what are all the collection interfaces available, and then we can also differentiate iterators and enumerators, and also we can differentiate what is list and set. So, in your later on session, so this is available in your util package, as I already told you. In your later on session we will see what all the other classes that is available in your util package, which is very important for your Java application development. So, thank you.